Hey, what's up guys? Today we'll use the Datamuse API in order to create a simple web application which helps us generate a sequence of related words. For this purpose we'll use HTML, CSS and vanilla JavaScript. Let's go! Okay, this is what we are going to create today. In the input field over here, we enter the initial word or expression. Could be any word or expression we like. Let's say summer. And submit by hitting the enter/return key. Now, summer becomes the first word in the chain of related words. By clicking on the current word, which is summer, we make a request to the Datamuse API for a list of related words related to summer. And once we have the list, we randomly select a word and add it to the chain. So if we click on summer, we get midsummer. If we click again on midsummer, again same procedure repeats. We get springtime, spring-like, sunny, shiny, glassy, shiny, burnished, shining, polished, refined, cultivated, etc. Also note that each time the mouse is over a word in the chain of related words, a new request is made to the Datamuse API for synonyms of the specific word, and a list of synonyms is displayed just as soon as the data becomes available. And that's all. Let's display one more example. Let's say JavaScript. Hit enter. This is now the first word in the chain. Click on JavaScript, XML, HTML, URL, website, web page, hyperlink, toolbar, route, poll, flagpole, must, post, succeeding, etc. Very nice. Let's start coding. Beginning with an empty project, we first create the index.html file. We type exclamation mark, it says Emmet abbreviation, we select this or hit tab or enter and we get some HTML5 boilerplate code. I'm using Visual Studio Code which comes with Emmet. If you don't have Emmet, you can easily install it or not. Emmet is just a plugin which helps us increase the speed of development. So let's change the title. The title will be related words with Datamuse API. And the HTML markup for this project is very simple. Basically, we will only have 3 elements which will be contained within a container. The first element is the input, where the user will be able to insert the initial word. I'll include the input inside of a form element with ID initial word form. We don't need the action attribute. And let's also add a placeholder attribute, enter initial word. We don't need a submit button or something because when we only have one input element inside the form, then by default the form is automatically submitted when we hit enter. The second element is the current related word which we can click on to get the next related word and so on. For this purpose we'll use an A tag with ID related word The A tag defines a hyperlink, and the href attribute specifies the URL of the page the link goes to. In our case, we don't want to link anywhere, that's why we'll use a hash sign. Actually, this now points to the beginning of the page. That's why some people use an exclamation mark alongside the hashtag. So now this points nowhere, given that we don't have an element with ID exclamation mark. But in any case, we will use JavaScript to override the default behavior of a click event on this element. And finally, the third element will contain the history / sequence of related words. For this purpose, let's create a paragraph tag with ID history. And obviously the content of this element will be dynamically populated. Okay, let's save and see what we've created so far. I'm using a live server, which also automatically reloads the page each time we save a change. Okay, but we can't see these two elements because they don't have any content. Let's add something. Save. Okay, and that's exactly what we wanted, but I think now it's a good time to add some styling. So let's move on to CSS. Let's first create the style.css file and link the document to the external CSS file. Okay. We won't expand on CSS in this tutorial, so I'll just paste the CSS code. You can, of course, find in the description a link to the full project. Here, for example, we import a new font family from Google Fonts API, the Montserrat family. There is nothing special in here. Almost half of the code in here is related to the tooltip, which is the pop-up with the list of synonyms which appears each time the cursor is over a word in the sequence of related words. Okay, let's save. We are almost there, but if you recall, there was a box around this word, and that's because the styling is applied to a span, which is a descendant of the history element. So we should wrap this word in a span. Let's do this right now. Save. Much better. So everything looks fine and we can proceed. But let's first take a moment to explore the Datamuse API. Here it is, and this is the documentation of the API. It's quite simple. So what is it? The Datamuse API is a word-finding query engine for developers. What is it good for? Applications use the API for a wide range of features, including autocomplete on text input fields, search relevancy ranking, assistive writing apps, word games, and more. And here are some examples on how to use it. This is the URL of the Datamuse API, and there are two main endpoints: the words endpoint, which returns a list of words from a given vocabulary that match a given set of constraints, and the SAG endpoint, SUG, which provides word suggestions for autocomplete. So let's look at some examples. In order to find words with a meaning similar to ringing in the ears, we would use the main URL of the API plus the words endpoint plus the query parameters. In this case, the ML, which stands for means like, plus the query term. So let's see what this returns. And let's first look at the interpretation of the results. For both words and SUG, the result of an API call is always a JSON list of word objects like so. We have a word and we have a score. Each list item is an object that contains a matching vocabulary entry word and some metadata, currently just an integer score. An empty list will be returned if no words or phrases are found that match your constraints. Note that popular multi-word expressions like hold dog are included in the default vocabulary, okay? For queries that have a semantic constraint, results are ordered by an estimate of the strength of the relationship most to least. So in this case, higher score means stronger relationship between the word and the query term. Otherwise, queries are ranked by an estimate of the popularity of the word in written text most to least, and at this time the score field has no interpretable meaning other than as a way to rank the results. Okay, back to our example. So for the term ringing in the ears, we have tinnitus as the most relevant word. Then comes ring, synchronism, agoasm, rings, singing, sing, sound, ear, hammer, jungle, mute, etc. Let's see the last words. We have cephalic, capital, canon, canon. Indeed, the last words seem to be less relevant than the first ones. And we will actually use this part in our related words sequence application. So for example, if we had the word summer here, we would get related words for summer: summertime, summery, spring, winter, autumn, year, midsummer, etc. If we had some word which does not exist, we would get an empty list. Okay. Let's quickly go through a couple of more cases and move on. So for words that sound like elephant, we use the words endpoint plus SL. SL stands for sounds like. Let's see what this returns. We get elephant, elephant, oliphant, oliphant, elephant, elephanta, elephants, etc. Notice that the score field in this case that does not have any interpretable meaning, but it's just a way to sort the results. In order to find suggestions for the user if they have typed in Rwand so far, let's see. The user who typed Rwand would get the following suggestions: Rwanda, Rwandan, Rwandese, Rwanda, Rwand, Rwanda franc, etc. They seem quite reasonable suggestions. So for example, here if we started typing web and let's intentionally make a mistake. So if we type this thing, we would get these suggestions: web developer, web development, web designer, web design. And personally, I'm quite happy with the suggestions because the first suggestion is what I actually wanted to type. So the autocomplete seems to be working fine. One last example would be to get the synonyms of a word. For this purpose, again in the words endpoint, we'll use the rel underscore syn for synonyms as query parameter. So let's see the example. This is not what we are going to use. We'll use the syn. So a synonym of ocean is sea. Let's see another example. Let's use the word passion. we get love, warmth, heat, rage, etc. And we will actually use this part in order to get synonyms of words for our application. Okay, enough with the Datamuse API. Let's continue with our project. We'll first create the JavaScript file and let's name it main.js. And let's console log something just to see that everything is working fine. Save, and let's open the console. Nothing is logged yet, and that's because we haven't linked the document to the external JavaScript file yet. We'll do this right here just above the body closing tag with a script tag. Name of the file is main.js. Everything is in the same folder. So now if we save, works. So now we are good to go. And by the way, technically the script tag could be placed anywhere in the document. However, by placing it at the bottom, we ensure that the document up to this point was loaded, which results firstly in a better user experience, since the page seems loaded although the JavaScript may still be loading, and secondly it ensures that up to this point we have access to the DOM elements. And let's quickly demonstrate this by trying to access the body from a script placed at the end of the body and from a script placed in the head. Let's comment this out for now. Save. So let's console log the body. As expected, we have access to the body and we get the body. Now, if we comment this out and uncomment this one, save, we get null. And that's because up to this point we don't have access to the body because it was not loaded yet. A way to get around this would be to use JavaScript in order to ensure that the DOM content was loaded before trying to use it. So let's do this here. So we add an event listener which listens for the DOM content loaded event, and as soon as the DOM content is loaded, the anonymous function over here is executed. This is somewhat the equivalent to the jQuery document.ready function. So if we save, we expect the body to be available. Indeed. So everything works fine now, but the loading speed could still be an issue. So let me show you one more alternative option. Save. Again, we don't have access to the body. And so by adding the defer attribute to the script element, we specify that this script should be executed when the page has finished parsing. So if we save, we can see that once more the body becomes available. Again, different ways to achieve similar results. You choose whatever makes more sense to you and try to be consistent. Let's continue. So what's the first thing we want to do here? Well, we want to be able to enter some initial word over here and pass this word to the anchor element and also add it to the history as the first word when submitting the form by hitting the return key. In other words, we want to modify or reset, to be more exact, the submit event of this form. We'll access the form element via its ID, and the ID of the form is initial word form. And once we've accessed the element, we will add an event listener to the form element object for the submit event. And let's console log something just to see that it's working fine. Save. So if we type something here and submit, watch the console, you can see that momentarily the word submitted is printed in the console, but then there is a page refresh and the word disappears. Let's watch again. Submit. And again. This happens because when the submit event occurs, the form is submitted since this is the default action. We can, however, prevent the default action from happening using the prevent default method, which basically cancels the event, therefore allowing us to subsequently override the default behavior of the event. Let's save. And now if we type something over here and submit, indeed we can see that the default submit event for the form was prevented and submitted is logged in the console. Nice. Let's continue. But first, let's assign to variables the DOM element objects we will need to access, so that we don't have to type all these each time we want to access an element, but just use the variable name instead. So let's define the variables at the top. And we'll use the const and let keywords for variables instead of the var keyword. So for the form element, let's name the variable initial word form equals, and let's assign the corresponding element to it. Let's cut this and paste it here. The reason I used const instead of let is because I'm not planning on reassigning any new value to this variable. So now if we copy paste this here, should still be working. Let's console log something. Save. And now if we submit, we can see that it works. Okay. Other elements we'll want to be able to access are the actual input element in order to be able to get its value, the anchor element over here, which represents the currently displayed related word, and the history element. Let's quickly assign these DOM element objects to variables. Let's paste this 4 times. And let's put the index.html side by side with the JS file. Okay, so So far we've accessed the form element. Now we want to access the input element. We can see that we don't have any ID here. We could add an ID and use the getElementById method, or alternatively we could use the querySelector method, which returns the first element that matches a specified CSS selector. We'll do the latter. And let's name the variable initial word input. querySelector. The input in here should be a valid CSS selector. So we want the input which is a descendant of the initial word form element. Next, we want to access this element with ID related word. And let's name the variable related word. And we also want to access the history element. Let's name the variable history. By the way, we don't need this hard-coded text anymore. Okay, now if we save, we can still see the test over here, and that's because I haven't saved the HTML. Okay, let's continue implementing the form submit event. What we want next is be able to access the input over here and store it in a variable. Let's name the variable new initial word input equals, this is the input element dot value. So this should now contain the input value, and let's console log. Let's type something here. Indeed, we can see the word test over here, but if we had some white space left and right and submitted, we would get the white space, and we wouldn't like that. And also we would prefer lowercase letters, just to be consistent with the Datamuse API letter case. For this purpose, we'll use the trim method, which removes white space from both sides of a string, and also the toLowercase method. Save. So now if we got some white space over here, some uppercase letters and some white space, submit, and we can see that we get the word test in lowercase letters and without white space. Nice, let's continue. Once we have the input value, we want to pass it to the anchor element, the related word element over here, and also add it to the history. Let's do this. Related word element dot text. So we'll use the text property, which sets or returns the text of an element. In this case, we will set the text of related word to the input value. Save. Let's test it. Submit. Indeed, we can see that the input value is passed onto the related word element. And let's also add the input value to the history element. We'll use the inner HTML property because this time we want to set HTML content and not just text. We'll use template literal, so backticks, span, here comes the expression, okay. Now if we save and let's test, looks fine, but we'd like to clear the input field value after submitting, so let's do this over here. Initial word input dot value equals the empty string. Save. Let's test now. Indeed, input value is cleared, but we would also like to remove focus from input element after submitting. We'll do this using the blur method. Blur. Save. Let's test. Submit. And everything looks fine. Just one small improvement we could make would be to check whether the input value is an empty string, and only proceed to this part if the string is non-empty. Otherwise it wouldn't make any sense if we entered an empty string. So if new initial word input, proceed. So in case of an empty string, this condition evaluates to false, and therefore this part is not executed. Let's save and test. Indeed, everything seems to be working fine. Now I'm trying to submit an empty string, and correctly it is not submitted. And before proceeding to implement the current related word click event handler, it should be mentioned that we could instead use ES6 syntax over here and the arrow function. So this should still be working. Or alternatively, we could instead of implementing the anonymous function over here, we could just add a reference to the function. Let's name the function initial word for submit, and implement the function separately. Notice that this is a reference to the function to be executed whenever this event happens. It is not an immediate execution of the function. This is not what we want. And let's see if everything works fine. Okay, again we have different ways to achieve the same results. Pick yours. And let's continue. Next, we want to be able to click on the currently displayed word, make a request to the Datamuse API and get a list of related words, randomly select a word from the list and update the currently displayed word as well as the history. So we are adding an event listener to the related word element. This is the related word element for the click event. And on click, we want the related word click function to be executed. Let's define the function here. So we cancel the default action when clicking on this hyperlink element. And next we want to fetch data from the Datamuse API. For this purpose, we'll use the fetch method, which is a global method provided by the fetch API. The URL of the resource we want to fetch goes in here. So let's find the URL. We are looking for words with a meaning similar to some query string. Okay, this is what we are looking for. So we could say that this is the constant part and this is the query string. So the URL would be the constant part plus the query string, which is this word over here. So we have related word dot text. This returns a promise with a response. The response should contain the data, but not in a usable format yet. For this purpose, we should use the JSON method on the response. We use JSON because the required data should be in JSON format. This also returns a promise. This time this should be the actual data in JSON format. Let's log it out. And let's also take care the error case. So in the case of error, we should catch the error. And let's just again log it out in the console. Nice, let's save and test if it's working. So now if we click on the currently displayed word over here, we should make a request to the Datamuse API and get a list of related words. Let's do this. Indeed, we can see that we get a list of words related to test. We get exam, examination, quiz, experimental, proof, assay, check, trial, pilot, examine, try, model, etc. So everything seems to be working fine. Now what's the next step? Next step is to randomly select a word from the list and update the currently displayed word as well as the history. So once we have the data, we will randomly generate the related word index. But for now we'll just set it to 0, and we'll also update the currently displayed word and the history. So related word dot text equals data related word index dot word, and also the history dot inner HTML. So we want to add to the already existing inner in HTML. We don't just want to assign a new value. Equals, and let's use template literals span closing tag, and in here goes the variable. So now if we save and test, looks fine, but we could also add an arrow each time pointing to the next related word of the chain, just to make it a bit more indicative. So the HTML5 entity for right arrow is this one. Save, test. Okay, looks better. Okay, now we can see that we've gotten into an infinite loop, and that's because we are always using the first element in the list. We'll fix this, but let's first take care of some other issue. If we had, for example, some word which has no related words and we clicked the word, we would get an error, says cannot read property word of undefined, and that's because it's trying to access the word property of an object which does not exist. So let's fix this by first checking if this indeed exists. Okay, this should fix the problem, because if it does not exist, if this does not exist, it returns undefined, which is falsy, and therefore this part is not executed. Let's save. So now if we click on a word which has no related words, we can see that we don't get any errors. Next, we want to generate a random number for the related word index. For this purpose, we'll use the math.random method, which returns a random number between 0 inclusive and 1 exclusive, times data.length. And we want to round this number downwards to the nearest integer. For this purpose, we'll use the math.floor method. So now this should return a random number between a random integer between 0 and data.length minus 1. Save, and let's test. Test audition, performer, showman. Looks fine, and it would totally make sense to leave it as it is. But if you recall, while examining the Datamuse API, it was mentioned that the first words of the related words list are considered, with higher scores, are considered to be more relevant than the last words. So what if, for example, we wanted to pick a random word among the first, let's say, 10 words of the list? Well, no problem. All we had to do would be to replace the data.length with 10. Save. Test. And now each new related word comes from the top 10 of the related words list. Okay, now if for example we had one here, then this would always evaluate to 0, and therefore we would get the infinite loop we previously saw. Let's check it out. Test, exam, examination, exam, examination, etc. If we had 2, I suppose again we would have many words repeated. Let's check it out. Test, exam, test, examination, exam, examination, exam, test, etc. Okay. A problem we might encounter would be in the case where the list of related words contains less than 10 related words, let's say 5, so in this case data.length would be 5, and if this evaluated to a number larger than 4, then this part would not be executed despite the fact that some related words exist. So let's quickly take care of this issue. Instead of always using the number 10 over here, we should instead use the minimum number between 10 and data.length. Okay, let's maximize the editor. And instead of 10 over here, we should use math.min data.length and 10. The math.min method will return the minimum between data.length and 10. So if for example data.length was 5, we would get 5. If data.length was 100, for example, we would get 10. If this was a very large number, we would most probably get the data.length. Okay, and we don't need this anymore. Let's save. And by the way, we could use a variable here instead of hard coding the value. And let's actually do this so that it will be easier in the future to control changes. So const, let's name the variable max related word distance equals 10. And let's add some comments so that if we come back in a week we can suspect what this is about. Let's say index of the next related word from related words array will be between 0 and max related word distance -1. So replace the 10 with the variable name, save, and let's make sure we haven't broken anything. Test, quiz, interrogate, interviewing, quizzing, chatting, socializing, and everything seems to be working fine. Nice, let's continue. An additional feature we could add would be to temporarily disable the related word element while the asynchronous fetch action takes place. For this purpose, we could add a class to the related word element which disables the pointer events, such as the click event, and remove the class later as soon as the asynchronous action is completed. So we have class list dot add, and the name of the class is disabled. The disabled class for the related word element was implemented in the CSS file. Here it is. So when a class disabled is present on the related word element, the pointer events property is set to none, and therefore the element will not react to pointer events. And also opacity is reduced. It is set to 0.5 just in order to visually show the user that the element is disabled. So if we click on the related word, we can see that it's disabled. We can't click on it anymore. But it remains disabled since we haven't removed the disabled class as soon as the action is completed. Let's do it over here. Related word dot class list dot remove this time disabled. Looks like we are back in business, and by the way, instead of using the add and remove methods, we could alternatively use the toggle method, which toggles between the class name for the element. And we would also like to make sure that in the case of error, the related word element does not remain disabled. So let's also take care of this. Looks fine. Let's continue. The last feature to be added will be the tooltip with a list of synonyms when the mouse is over a word in the chain of related words. However, the span elements containing related words are dynamically created and they do not exist when the page is first loaded. So how can we add an event listener to a dynamically created element? Well, one approach would be to add the event listener to the newly created element at the point of creation. Another approach would be, and this is actually the approach we are going to follow, to add the event listener to a static ancestor of the dynamically created element. In other words, to add the event listener to an element which already exists when the page first loads. In this case, the history element is the direct ancestor of the dynamically created span elements. We could of course alternatively add the event listener to the container element or the body element or even the whole document, but it makes more sense to add the event listener to the parent of the dynamically created elements in order to limit the domain of the event listener as much as possible. Okay, back to coding. So we'll implement the event listener for the mouse over event for the history element. For the mouse over event, and when the mouse over event happens, we want to call the history mouse over function, and let's implement the function over here. Function history mouse over event, and for starters, let's just console log something. And let's console log the ID of the element. Okay, let's see what happens. We notice that nothing is logged in the console when we mouse over the page, and that's because the history element is currently empty and doesn't occupy any space in the browser window. So let's add an element. We can see that when the mouse is over the history element, history is logged in the console. And do notice that history is a paragraph element, and therefore it's a block level element taking the whole line. Now, how can we specifically target the span descendants of the history element? Well, we can do this by adding an if statement which checks whether the event target is a span element. So if event.target.tag name, the tag name property returns the tag name of the element, and in HTML the return value of the tag name property is always in uppercase. So if event.target.tag name equals span, then console log history span. And let's see what happens now. Let's add an element. We can see that history span is logged in the console only when the mouse is over the history span element. Let's add some other elements. So looks like up to this point we've managed to correctly target these dynamically created elements. Now this is 100% correct. However, I feel more comfortable controlling the letter case, just in case. So I will convert the tag name to lowercase. And let's make sure that everything still works fine. Nice. So now we want to make a request to Datamuse API to get a list of synonyms of the target word. And by the way, how can we access the target word? Well, if you recall previously, we used the .text property for the anchor element. However, for the span element, the text property does not exist. And let's quickly demonstrate this. Event.target, this is the span element, .text, save, test, and if we hover over, we get undefined. Okay, so instead of text, we should use text content. Text content is quite similar to the inner text property, but not the same, and it returns the text content for all elements. So if we save, test, we get test. Nice. And by the way, we could also replace the text here with text content. And again, same functionality is achieved. Okay, let's save. Nice. And now for the fetch request to Datamuse API, let's copy and modify this part. We won't need this. The URL up to this point is the same. Here we will use rel underscore syn syn plus, this will be event.target, and let's remove this part and just console log the data. Save. And now if we mouse over the word in the history section, we can see that a list of synonyms is logged in the console. So for the word test, we have run, which is not exactly a synonym to test. I mean, we ran a test, but I don't exactly know how synonyms from the related words list are chosen. We get run, check, model, screen, trial, pilot, proof, assay, try, essay, examine, quiz, examination, exam, experimental, tryout, psychometric test, mental testing. Okay, so now in order to show the data to the user, we'll set a custom data attribute to the target span in order to store the data. So we have event.target.set attribute, and we'll name the attribute data tooltip, and we'll set a value to the attribute. We have data, this is the data, and it's an array of objects. As a first step, let's get an array of words. Data dot, we'll use the map method. So for each element we want the word name field. So we have syn dot word. Nice. So up to this point we have an array of words, and let's use the join method to join the elements of the array into a string. Okay, and by the way, data tooltip is styled with CSS using attribute selectors. Here it is. And by default, the data tooltip is hidden, and it only becomes visible on hover. Okay. So let's see what we have up to this point. Looks fine. However, 20 words seem like a lot to me, and what if there were more than that? So it would make sense to limit the number of displayed words to, let's say, a maximum of 10 words. So let's do this. We'll apply the slice method over the data array, which returns a new array with the selected elements. In our case, we'll select the elements starting from 0 index up until, but not including, the 10th index. So up to this point, we select the first 10 elements of the data array. But what if data only had 2 elements? Well, in this case, we've seen this before. The second argument should be the minimum value between the data dot length and 10. Save, and let's test. Looks fine. And let's test for less than 10 synonyms. I think ocean only has one synonym. Okay, we get C. And what if we have no synonyms? Well, in this case we get an empty tooltip. We could, however, inform the user that no synonyms were found, and let's do this right now. So if data.length, if this is greater than 0, then it evaluates to true. Else, in this case, we'll set the data tooltip value to synonyms not found. Save, and let's test. Nice. JavaScript. Synonyms not found. Okay. Now, one more improvement we could make would be to avoid making requests to Datamuse API if the data tooltip attribute already exists, since in that case it would mean that we already have the data and there is no need to request it. So let's do this. Before proceeding to the request, we also want to check that the target element does not already have the data tooltip attribute. So if not event.target.has attribute data tooltip. So only proceed to the fetch request only if the target element is a span and the target element does not already have the data tooltip attribute. And that's all. Now, if you prefer one-liners, obviously this could be replaced with a single expression using the conditional ternary operator. And let's quickly do this. Let's comment this out, and this will be replaced with this one. Then data. So the condition is this one, if data.length, and if this condition evaluates to true, then this part will be executed. Else, this part will be executed. Nice. Let's test and wrap it up. Test, experimental, pilot, pilot program, project, picture, movie, picture, impression, effect, and on mouse over we get a list of synonyms. Let's try another word. JavaScript, XML, XSL, query language, schema, schematic, formal, dignified, formal, And that's all, I guess. So we've managed to use the Datamuse API to get words related to an input word and also get word synonyms. So what else could you create using the Datamuse API? Well, obviously many things. For example, you could create a game where you give the user a specific word and have the user type, for example, in 60 seconds, as many related words as possible. And if the words exist in the related words list, add the corresponding score and end up with a final score. Or, instead of related words, you could have the user type words that rhyme with the given word. And you could also use a speech-to-text API so that the user wouldn't even have to type the words. Although I'm not sure how well a speech-to-text API would perform for single words. I think they perform better for larger expressions or full sentences. You could also use the Datamuse API to create word search games and many other word-related games, or you could use it to create word clouds for a given word. And let's see what a word cloud is. So, for example, this is a word cloud. The size of the word is usually defined by the frequency a word appears in a text. In our case, we can make the size correspond to the score of a word. So given a word, we can create a word cloud. Or, as mentioned in the documentation, we can use the Datamuse API for a wide range of features, including autocomplete on text input fields, search relevancy ranking, assistive writing apps, word games, and more. Okay guys, that's all. Thanks for watching. For any questions, suggestions, opinions, or just to say hi, please use the comment section below. Like if you liked, subscribe if you want more. Keep coding, keep improving, and enjoy the journey. Bye.